Welcome to The Explainer. Today, we're going to pull back the curtain on the invisible language that runs our digital lives. From your streaming queue to your shopping cart. We're talking about SQL, the language that secretly powers the modern world. Let's dive in.
I mean, have you ever really stopped to think about that? How does a huge company keep track of every single click, every purchase you've ever made, every show you've binged, and then find any tiny piece of that information in the blink of an eye? It sounds kind of impossible, right?
Well, the answer isn't magic. They have a system, and that system is controlled by a very specific and very powerful language. That language is SQL, which stands for Structured Query Language. Now, I know, that sounds a little technical, but here's the best way to think about it. Imagine a database is a massive, perfectly organized library. SQL is the special language you use to talk to the librarian. So in this explainer, that's exactly what we're going to do. We're going to build our own data library right from scratch in 5 simple steps. We'll start with the basics, then build the blueprint, set the rules, fill it with data, and finally, the fun part, learn how to ask it some really smart questions.
So, first up, what exactly is SQL? Let's get to know our data librarian.
Turns out this librarian language really has 3 main jobs, each with its own fancy name. First, you've got DDL, which is the language for actually designing the library itself, the blueprints. Then there's DML, which is for all the day-to-day work. And finally, you have DQL, which is how we find the exact information we need. It's the magic part. Okay, let's start with DDL, the data definition language. You can't just throw books into an empty room. That would be total chaos. First, you have to build the shelves. You have to create the actual structure that's going to hold all your information. In SQL, the main command for this is create table. And you can think of a table as a single, dedicated bookshelf. You might have one for employees, another one for products, and a third for sales. This command is what lays the foundation for everything else we're going to do. When we're building our shelves, we also have to decide what kind of information each section is going to hold. These are called data types. You wouldn't store a book's price as just random text, or its title as a number, right? That'd be messy. Using the right data type, like int for whole numbers or varchar for text, make sure our library is super efficient and accurate from the start. But even then, choosing the right type is so crucial. For example, look at the difference between char and varchar for storing text. If you use char to store a 6-letter name in a space that's built for 10 letters, you're literally just wasting 4 spots of memory. It's like a box that's always too big. But varchar is way smarter. It's like a variable length box that shrinks to fit the name perfectly, wasting 0 space. Choosing the right one has a huge impact on performance, especially when you have millions of records. Okay, our shelves are built, but a library without rules? That's just chaos waiting to happen. So our next step is to use SQL to define the rules, or constraints, that keep our data clean, organized, and totally reliable. These rules are really simple, but incredibly powerful. A not null constraint just means a piece of information, like, say, an employee's name, can never, ever be left blank. Unique makes sure we don't accidentally add the same product twice. And the primary key, well, that one is really special. The primary key is probably the single most important rule for any table. It's a unique identifier that is guaranteed to be one of a kind and never empty. Think of it just like a social security number for a person, or an ISBN code for a book. It's the one piece of info that lets you find exactly one record with 0 confusion. So, our library is built and the rules are in place. Awesome. Now it's time for the librarian's actual day-to-day work. This is where DML, or data manipulation language, comes into play. These are the 3 core commands you'll be using all the time. Insert is for adding a new record. That's like putting a new book onto the shelf. Update is for changing something that's already there, like fixing a typo in a book's title. And delete, well, that's for getting rid of records. Now, when it's time to remove data, you've got a few different tools. The delete command is surgical. It's very precise. It uses a where condition to remove very specific records. For instance, you could say, delete the book where the title is Moby Dick. Then you have truncate, which is way more drastic. It removes every single record from the table all at once. It's like yanking all the books off the shelves, leaving them completely empty but still standing there. And finally, you've got the nuclear option, drop. This one doesn't just remove the books, it completely demolishes the shelf itself. The drop table command deletes the entire structure and all the data inside it, and it's gone for good. Okay, we've built the library, we've set the rules, and we've filled it with data. Now for the payoff. This is why we did all that work in the first place, to be able to ask questions and get answers instantly. This is DQL, or Data Query Language. The command to ask pretty much any question is select, and the simplest query you can possibly write is select star from emp. That little asterisk is just a wildcard. That means everything. So this query basically translates to, hey librarian, show me absolutely everything you have on the employee shelf. And what you get back is the entire table. It's useful, sure, but it's kind of like asking for one book and having the librarian hand you the whole shelf. It's often way more information than we actually need. The real magic happens when you add one more word, where. The where clause lets us filter the results based on any condition we want. So now our question becomes so much more specific. Show me everything, but only for the employees where their job title is salesman. And just like that, our huge list is filtered down to exactly what we wanted. We went from a massive data dump to a specific, actionable insight in a single line. This is what SQL is all about. So there you have it. We went from a totally empty room to a fully functioning library. We built the shelves with DDL, we set the rules with constraints, we managed the collection with DML, and finally, we got the answers we needed with DQL. You now understand the fundamental language of data. So the only question left is, what would you ask?